Ryōiki Tenkai. The domain of a linear function part 2. Here we have another function which is a linear function given as f of x is equal to 4 minus 5x, and we are going to determine the domain and the range of a linear function represented by this function. The domain is a set of all values of x that can be substituted in our function that will give us a real value, or the result will still be a real number for our f of x. We can rewrite our function here as a combination of x and y coordinates, or x and y variables. F of x can be written as y equal to 4 minus 5x. And we are going to establish here a process in determining the domain and the range of this given equation that is actually taken from our function. As mentioned, the domain is a set of all possible values of x that can be substituted here. By the way, the domain and range for all linear functions are just the same, but we are going to illustrate it here as to how do we determine that further. Now, looking at this, let's take or think of possible values of x. If x is a positive integer, we have, say, 1. 5 times 1 is 5. 4 minus 5, negative 1. That's the value of y, a real number, so it's possible. If it's a fraction, let's say 1/5. 5 times 1/5 is 1. So 4 minus 1 is a 3. Also a real number. Even if we're going to take negative integers such as negative 1, 5 times negative 1 is negative 5. So 4 minus negative 5, that's positive 9, a real number. And even the inclusion of our irrational numbers such as square root of 2, the value for y is still a real number. In short, the domain for this given linear function is a set of real numbers. Set of all real numbers. Because no matter, as long as you will be using a real number value for x, you will always get a real number value for your y. The range, on the other hand, is a set of all possible values of y taken from the possible values of x. We could establish here a method of determining the range by solving for the value of x in terms of y on a given equation. In short, we are going to treat this in such a way that we're going to solve the value for x. So with that, let's try to copy it here. Y is equal to 4 minus 5x. So to retain only x on one side of the equation, let's subtract 4 here. That will become 0. You have minus 4 here as well for properties of equality. Therefore, you have y minus 4 is equal to negative 5x. If we are going to divide both sides by negative 5, same as here, you will get this expression as you are going to cancel that out. Using symmetric property, the value of x here is the expression y minus 4 all over negative 5, or you could also place a negative sign in the middle. Looking at this, since our y can be found in our numerator, we can substitute there any real number. There is no restriction as to the value of y. Because if we're going to substitute here 1, the result for x is a real number. Even square root of 2, even 1/5 or 1/2, the value of x is still a real number. In short, the range for a linear function represented by the given function is also the set of all real numbers with no restriction. To illustrate it further, let us have this Cartesian plane. By graphing the said function in our Cartesian plane, you could also analyze if there are restrictions or the possible values for all x, which calls for our domain, and for our y, which calls for our range. Let's use the original equation here, or the equation including y. And if we're going to substitute x being 1, you will have here a value of y. Okay, you will have 5 times 1 is 5, so 4 minus 5, negative 1. This is one of the points on the Cartesian plane. And take note, this is a linear function, so our graph is a line, and we just need 2 points to draw the said line. If we are going to have x be equal to, let's say, negative 2, okay, just a play for values, but of course you could pick 0, 2, negative 1, depends on you. Using this, you have 5 times negative 2 is negative 10. 4 minus negative 10, that's positive 14. But since my Cartesian plane here will not cater such number, so let me brought it down to negative 1. So 5 times negative 1 is negative 5. 4 minus negative 5 is positive 9. So our y here is 9. Now these 2 points here, if x is 1, y is negative 1, this is your first point. Next, if x is negative 1, your y is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The point is here. Connecting these 2 points using a straight line, this would be the graph of the linear function represented here. As you can see, it leans towards the left, or from left to right it goes downwards, because if you can remember, yeah, the slope here is negative 5. Either way, the point here is, if we're going to look at this, and of course this extends further down and further up, and we know that the horizontal axis is your x-axis and the vertical axis is your y-axis. As you moved from the center point or the origin towards the right, using all possible values of x here, you would see that this line will just continue on going down, and moving towards here, it will just continue going up with no restriction. This is the analysis that there are the possible values of x are all real numbers, no restrictions, because there are no breaks on our line. Same goes through with the possible values of y. As you go down, it will extend there, and as you go up, it will extend further. This is the proof that the domain and the range of a linear function given here are both the set of real numbers with no restriction. For the next functions, please do not forget to like this video, share this, comment down, and subscribe to our channel. It is for us to expand further.